Okay, let's look at some examples where we're condensing and expanding logarithms. This might seem kind of silly, but it's very useful in calculus. In calculus, when you're taking derivatives, when you have things that are added or subtracted together, it's really easy to deal with. When you have things that are multiplied and divided, it can be a bit of a pain. So this is actually going to be useful for you when you take calculus. So let's use the log rules to expand this thing as much as possible. The idea here is each one of these things inside of these parentheses is going to wind up with its own logarithm. And when I say each of these things, I mean each factor. On top, we've really just got one factor. On bottom, we've got two. We've got 36, and we've got y to the fourth. Each one of these is going to wind up in its own logarithm. So first up, I'm going to do these first few in several steps, but then we're going to see sort of a shortcut, and these problems are going to turn into something that can be done really quickly. All right, so this one, we've got a subtraction. So this is log of cube root of x minus log of 36y to the fourth. Okay, so we've got over here, this is two things multiplied together. So let's break that out. Log of cube root of x minus, let's split this into log of 36 plus log of y to the fourth. All right, now we've got a negative here that needs to distribute across these. So log of cube root of x minus log of 36 minus log of y to the fourth. So this becomes, let's rewrite this. Log of cube root is the same thing as x to the 1/3. And tell you what I'm going to do. This wouldn't be absolutely required, but since 36 here is since 36, we know that's a perfect square. Let's rewrite it as 6 squared. And so now I can use the power rule to bring all these things down front. 1/3 log x minus 2 log 6 minus 4 log y. And that is expanded as much as possible. Now, let me say something about this. Having a 6 squared there, it's fine to leave this as log of 36. Some people, and I imagine the book would probably write this as 2 log 6 instead of log 36. It's kind of like, it's kind of similar to, say, in the square root of 12, but that's a multiple of a perfect square, so it would make more sense, or maybe not make more sense, but we could rewrite it as this, and in some sense this is a more simplified version 2 root 3, because there's no perfect square under the radical anymore, or no multiple of a perfect square under a radical. Same kind of thing going on over here. Inside of a log, the most simplified way to write it is to not have any power inside of here. Any perfect power, like a perfect square or cube or whatever. I'm not picky about that, but if you did this problem and you got this for your answer and saw this in the back, you should know what the you should know that they're the same. All right, this next example is very similar. We've got natural log of x squared minus natural log of y cubed w to the fourth. And now I can split this into the natural log of this becomes natural log of y cubed plus natural log of w to the fourth. When I distribute my negative, I get minus ln y cubed minus ln w to the fourth. So it's 2 ln x minus 3 ln y minus 4 ln w. Now that's writing out all the steps. But notice what happens on here. The term on top gives us this log. And down here, each of these terms give us a negative log. So, if you just look at this and sort of see the pattern, you can go from the original straight to the answer. The thing on top gives me 2 ln x. The bottom, both of these are going to be subtracted. So minus ln y cubed minus ln w to the fourth. And then use the power rule. So after you do these a bit, you can do them really fast. All right, let's look at this one. This one, notice on top we've got 4x squared. So let's think of this as being two things on top. And on the bottom, we've got 3x plus 1. Since those are added together, we can't split them up at all. This is going to break into log base 2 of 4 plus log base 2 of, I could do x squared. Let's go ahead and move that square down front. Then minus log of 3x plus 1. And can I do anything to this? Yeah, I can evaluate that. Log base 2 of 4 is 2. Like that. And I just realized I lost my 2 there. Let me put that back in. Okay, this one, we've got a term on top and 2 terms on top and 2 on bottom. So 2 here, 2 here. So we're going to wind up with 4 logs here. The 4 logs we get are going to be, the top would give us ln of e cubed. I'm going to move the 3 out front. Then ln of x to the fourth. But I'll power rule that 4 out front. And then the next 2 are going to be negative. Ln of 5 plus x squared. I'll put it out front. And then minus ln of x plus 1. I was about to circle that, but I'm not going to because we can't simplify one thing. That first thing, 3 natural log of e, that's 3 times 1. So this is my final answer. Okay, got another one of these questions. Is this equal to that? And usually these are tricky things. The answer here, again, is no. The quotient rule says this. Log of x over y is log x minus log y. That's not what this is up here. This is a quotient where you've got a log on top and bottom. This is a log of a quotient. So this up here, this is a common mistake people make. So don't fall into that trap. All right, let's do a few more of these. We did 4 examples of expanding. Now let's condense these into a single logarithm. All right, so when you do this, the main thing is first, use the power rule to eliminate the coefficients. Then use product and quotient rule to combine. All right. So let's do this. This one here, this is going to be, let's see, all my logs are are the same base, so that means we can actually do this. So this one is going to be log base 2 of 3 to the third. Let's go ahead and write that as 27 minus log base 2 of x squared plus log base 2 of, let's see, we're going to get this to the 1/2 power, so I'm going to write that as square root of x plus 1 minus just log base 2 of 7. Now each of these that has a positive in front becomes a part of the numerator, and the negative ones become part of the denominator. So let's do this. This becomes log base 2 of big fraction 27 on top, x squared on bottom, square root of x plus 1 on bottom. Wait, no, that goes on top. Since it's positive. And then 7 on bottom. I'm going to put the 7 in front. A little lopsided, but that's okay. All right, one more. Now looking at this, we've got several things. One thing you might notice, we got 4 natural log x and then another 4 natural log x. So we could combine that into 8 natural log x if we wanted to, but let's not do that yet. Let's go ahead and just write this up. We get natural log of x to the 4th minus natural log of z to the 5th minus natural log of z to the, let's see, that'll be 3 to the 3rd, or not 3 to the 3rd. Tell you what, let's write it like this. 3z cubed times raised to the 3rd, that'll give us z to the 9th. Then natural log x to the 4th, then minus natural log of z. Okay, now I can put this all into one big natural log. Let's see, x to the 4th on top, z to the 5th on bottom, z to the 9th on bottom, x to the 4th on top, and then z on bottom. So now I can put this together and get natural log of, on top, x to the 8th over z to the 15th. Now, if I'd wanted to at the beginning, I could have combined this and this together to get natural log of x to the 8th. And if I had done that first, then I would have, this and this would have been a single log, natural log of x to the 8th, and it would have led me here. So, you can combine them in the beginning by combining like terms, or you can just put it together and then you wind up multiplying the x to the 4th together. Either way, you get the right answer. All right. Now, there's a worksheet on worksheet 2. This is on course then, and it has the 3 properties, and it has several problems asking you to write these as, let's see, doing some expansions and some condensing as well. Yeah, write as a single log. So this is, in addition to the homework, this is a good bit of practice for doing this stuff.